Hello, and this time looking at surds, but specifically rationalising the denominator. And this is a really big thing. Well, it's not a huge thing, but it's an important skill, and you always see a question on this on GCSE and A-level papers somewhere. I say always, maybe not always on GCSE these days. You definitely used to see them at least once on both papers, but maybe not so much anymore. But it comes up quite regularly, and it's something that people are quite keen on. I'm not sure why. Like mathematically, there's no difference between this fraction and a fraction which has a rational number, so not a surd, on the denominator. So I don't know whether it has a good use later on in your mathematical life, or if it's just a nice little method to learn so that you have that ability to do it and another skill to muck about with the algebra and rearranging and things like that when you need to. So I'm not sure which it is, but in any case, it's in the exam, so we need to be able to do it. So what is it? I've kind of already said. It's looking at a surd with a fraction, or a fraction with a surd in, I should say, and making the denominator a rational number, which means no square roots in it, which means if the top was rational, it will get a square root. We're not going to be able to, completely remove square roots from this. It's just that we don't want them on the denominator. We'll have them on the top, but I want a nice whole number on the bottom, and that'll make me much happier. And it's quite an easy thing to do. When it's these simple examples, you're just going to times the top and the bottom, equivalent fractions. We don't want to change the actual number, so times the top and bottom by the surd on the bottom. Easy peasy. So if we times that by root 5 and times the top by root 5, equivalent fraction, perfectly legit. 1 times root 5 on the top is root 5, and root 5 times root 5, well, because I'm squaring, I'm timesing by the same thing, it's the square roots cancel. It's just going to be 5. Or you can think about it as root 5 is root 25, which of course is 5. And there you go, that's it, rationalise. Sometimes you can cancel the numbers, but in this case, that's it, root 5 over 5. And if you've got a calculator like this that gives you answers in surd form, then if I put that in, 1 over root 5, it generally will give it to you in the rationalised denominator form. So you can sort of check your answer on the calculator. But you do need to show some working out usually, so don't just do it on the calculator in an exam if they do give you numerical ones. They often throw a curveball in because they know your calculator will do it these days. Okay, so 4 over root 2, same thing, times the top and the bottom by the root 2, times the top by the root 2 as well. And then what do we get? We get 4 root 2 on the top. Root 2 times root 2 is 2, and this will cancel. 4 over 2 is 2 root 2. Lovely. And we could try that on the calculator just to check that we're not going crazy, not made a simple mistake. 2 root 2, there we go. Now, if there's some bonus stuff here, if it's times by something, you don't need to times by that as well. So you don't need to do 2 root 2 and 2 root 2. All that's going to happen is the 2's will cancel. You can just times by the square root bit. Okay, much easier that way, so you don't have to go up to big numbers and come back down with cancelling. So 3 root 2 there. 2 times root 2 times root 2 is 2 itself, and of course we can simplify that. 2 2's are 4. Now if you can't do that in your head, then write 2 times 2 and write it out again. 3 root 2 over 4 simplified, yeah? That's perfectly legit. In fact, it's better in a way to show that level of working out, but if you can do it in your head, it won't matter in an exam situation. If you've shown something like this, that's the sort of the method, but times there. But it is a little bit different if there's a plus or a minus. Okay, so let's just try the same technique, but it's not going to work. So if times both by root 3, great. Times by root 3, it looks like it's going to work. 1 times root 3 is root 3, and then the root 3 times root 3 is going to cancel. But look, 2, if that's in a bracket, yes, times in the whole thing, 2 times root 3 is 2 root 3 minus, and that's going to cancel and give us a 3. So we've still got a root on the bottom. Drat. So what we have to do is something a little bit clever, and we're going to use the difference of two squares. And if you haven't seen this before, most people see it when they do quadratics. If you have x squared minus a square number, If you're used to doing double brackets, you might have seen something like x squared plus 2x plus 1 or something like that. And, well, that gives me a repeating function, so let's not do that. Let's have 3 there, and let's have 4 there. And you might have done this before, where you put x times x is x squared, 3 is 3 times 1, and then, so you get x times x squared, 3 times 1, 3x and 1x add together to give 4x. When you've got the difference of two squares, you can solve this by doing the square, same sort of idea, the square root of that plus the square root of that, and the square root of that minus the square root of that. And that way, what happens is you get x squared, great, you get minus 5 times 5, minus 25, and then you get positive 5x and negative 5x, which cancel, which is why we haven't got a term in the middle. And that's what we want, because if we have the root times the root, that's fine, but when we have the root times the number, well, it's like getting 5x. So we need minus the root times the number as well to get the other one, and then cancel it, and the roots disappear. So that's why we're doing it. And so if you have seen difference to two squares and always thought, what a peculiar little novelty to learn, it crops up here and there, and you also see it in complex numbers at A level. If you do complex numbers, if you do enough A level maths to cover that, then it comes up with complex conjugates and things like that as well. So really, really useful to remember that as a little trick. So what we're going to times by is not root 3, but we're going to times by 2 plus root 3. 2 plus root 3, top and bottom, in brackets. 1 times isn't going to do anything, so we can just write it as 2 plus root 3. And here we get 2 times 2 is 4. We get 2 times root 3 minus 2 times root 3, which cancels, and then we get minus root 3 times minus root 3 times root 3, which is minus 3, because the roots cancel out. Okay, which we now need to, we can just work this out because it's just numbers. So we get 2 plus root 3 over 1. Well, actually, we don't need to put over 1. So there's our answer. Okay, we probably should put an equals here every now and again to show sort of the levels. But there we are. Same thing here. It looks more complicated, but it's really not that bad. We've got 3 plus root 2, and so we're going to times by 3 minus root 2. Same thing, but change the sign. And remember, we've got it, let's put brackets round so we remember to times the whole thing. We're going to times the top by the same thing as we've times the bottom, because we're doing equivalent fractions. What sometimes people do is they sort of do the opposite of that one with the minus sign, and then they times this by 1 plus root 2. They do the opposite of that. No. You've got to times the top and the bottom by the same thing. So it's the denominator you're rationalising. Whatever you do to rationalise that, you do the same times on the top for an equivalent fraction. Otherwise, you're changing the value of the number. Right, on the top is the more complicated one. We've got 1 times 3 is 3. We've got 1 times minus root 2 is minus root 2. We've got minus root 2 times 3, which is minus 3 root 2. And minus root 2 times minus root 2 is positive 2. All over, 3 times 3 is 9. The 3 root 2 minus 3 root 2 cancels, and then we get minus, because it's minus times a plus, 2, because the roots cancel. And we can then simplify this quite nicely. 3 add 2 is going to give us 5, and minus root 2 minus 3 root 2 adds up to 4 root 2s, minus of course, and this is over 9 and 2 give me 7. Nothing cancels. Sometimes, if that number and that number both contained a same factor or something on the bottom, you could cancel it, but I think that's it. Of course, you need all that working out in the exam, but there's nothing to stop you just typing it in. Fraction 1, if you have this kind of calculator, of course, that will do surds for you. Now, it won't do all of the most complicated ones, but hopefully, there you go, it will do that one for us. 5 minus 4 root 2 over 7. So it gives you confidence that you're right, because if you have gone wrong and then this is wrong, you must have typed it in wrong and done a mistake. And if you do that in the same way, so you happen to get both wrong answers, that's got to be pretty unique. So I'm pretty confident that must be right. Okay, I'll leave it there. If you have any questions, then pop them in the comments down below. But otherwise, cheerio.